Alright everyone, how we doing? Alright, so to get back to what we were doing, I'll try to figure out if I can save that other video we were doing. Sorry for that technical difficulties, but let's get back to work. So if we were to recall what we were doing, okay. I don't have my face cam on now, but we can try this. So okay, so to explain to what happened to me right here, apparently not all these sockets, or let me see, like these sockets that are on the wall, I don't know if you can see that, they don't work. I can't show you that, but the point is I was plugging my laptop in there, but it wasn't charging, and I was like, what? So yeah, that's something I gotta talk to Dr. Greg about. But alright, to summarize what I was trying to do, let's verify I'm recording. Okay. So what I was trying to say right now was, the first thing everyone's got to know is a function is a rule that assigns to each element x, which is a subset of x, which is a part of a set x, a unique element in f of x, which is also a part of y. And then I defined another word too, if you guys wanted to. So that's like the first part of the quiz I was trying to hopefully explain to everyone. And oh yeah, that's my stuff right there if you want to see that. Let's see, is it right here? Yep, alright, so now let's go over the second question that I have right here, if anyone's following along, which is for the following values, from -2 to n to 2, plot the function this. Y is equal to -2, 0, 1, 3, 2. Now I say to label your functions. So why did I put this question on? It's really trivial, right? But then once people get to the Matlab assignment, their brain just goes to mush. And then they're like, what's going on? And I'm like, no, come on. So let me pull that right here. Just change this right here to 1. And let's put this to 2. So what I gave everyone is for, given this range, -2, n to 2, I give you y is equal to -2, 0, and I can't remember the numbers I put in there. 2, 0, 1, 3, 2. 1, 3, 2. Right? So we see that, right? How would you plot this? So really simple. If you were to draw this like this, draw your axis. This right here is defined as the n-axis. 2, 1, 0, 1, 2, right? -2, -1, 0, 1, 2, right? Everyone's seeing that. It's so simple, so elementary. And then let's just define this as a -2. Let's put it in a different color, like green. Yes, perfect. It's 2, and we'll put 0 right here. And then 1, let's just put that right here. Then 3, and then 2. It's 3, 2, 1, 0, -1, and 2. And then this axis would be the, well, axis y, because this is the values of y that are in a range. So you see that right there, right? So now the next thing I'm going to try and get everyone to is an intro to Matlab. So now I want to tell everyone, has everyone installed Matlab at all, or figured out how it works, or did anyone actually try to get it for free? No? Yes? Yeah. It's all free on the UNLV computers here. You can also have this at home if you prefer. So I can see a lot of people saying yes, yes, yes. So that's really good to hear. So, oh yeah, and then, oh, I have solutions. So you like that? You want me to click that? Just kidding, nah. I'm going to make sure everyone knows how to produce their own unique code. Make sure everyone knows. And I use this for a lot of research too. I should probably keep that open. It's okay. But MATLAB basically stands for Matrix Laboratories. So it's basically a program where it just works as a matrix. If I were to do some examples, let's do MATLAB. So MATLAB it basically stands for Matrix Laboratories, and you get that cool little I'm going to draw the MATLAB symbol. Whoa, there you go, MATLAB. There you go. So basically everything is done using matrices. So you can either have a vector, you can have a vector which has 3 blocks, 1, 2, 3. And then what happens if you wanted to or add this plus to another matrix? 4, 5, 6, right? So if you were to add this, let's say this is row 1, and then this is also row 2 or something like that. And then column 1, 2, 3. If we were to add this, this would add here to here. I'm going to show how this works. If we were to add this to this, this to this, and this to this, we would get 5, 7, 9, which is also a little vector, so everyone can see how we're going to try. So I'm doing this example. It's really trivial, but it gets to the point where people are like, I don't know, it's going crazy. Let's see. Oh, just get the R2021 version. See that, Heart? Yep, there you go. Yeah, don't get the extra program. I think the only programs everyone should be installing are the DSP controls package. We're going to use the controls at the end of the semester because we're going to do a lab, which is an analog and a digital lab. So that'll be fun to have. But for now, we just need MATLAB Simulink. We'll probably not use it. Back in the days, they tried it, but I hated it because no one knew how to generate it. But I'm going to try and make sure everyone knows how to do everything in MATLAB. So, all right, so you see how easy this is, right? So then what happens if I get to the problem where I'm like, okay, I'm just going to have this square right here, right? Just 1, 2, 1, 2, right? But if I were to add this to a square which is a different size, 1, 2, 1, 2, 3, right? If I were to add this, MATLAB's not going to know if I should add this to this, or if I should add this to this, or then it starts getting confused and it doesn't like that, then it spits an error. So let me explain what I'm going to try and do. So basics. Step 1. Let's see. Matrices. So if anyone wants to try this at home, let's define A is equal to, let's do this. 1, 2, 3. Oh wait, there you go. Wait, nope. That's not it, sorry. I had a brain fart. There we go. So, oh yeah, I think everyone's trying to ask, how do you get to this? If I were to open up MATLAB for the first time, there's this plus sign right here. You can go to New Script. It gives you a new script to play with. So just in case you wanted to know that. And how's the chat doing? Chat's doing pretty good. Alright, so the first thing everyone's going to learn is actually, why did I do this? Man, I'm completely forgetting my MATLAB, sorry. Okay, so the first thing I'm going to try and do is tell everyone what this window is. So this right here is the command window. The command window is basically stuff you can code in. So the first command I'm about to show everyone is CLC, which basically says clear command window. So that clears and makes sure everything's clean. Then the next window I'm about to show you is clear vars. So this is a function. See this workspace right here? You have stuff saved to that. Press enter. Gets rid of all that stuff just in case. So just in case you don't want to like have variables jumping around everywhere. Then CLC to clear the command line again. So So before I even code here, I'm going to show everyone you don't need to script. You can use this as a calculator. Now if I can turn on my camera. Can the camera turn on? Come on, is it going to work with me? I want to see everyone's faces. Okay, turn off the camera, turn on the camera. Let's try that. Start video, HD webcam. It won't let me, whatever. So first thing I'm going to try and do is define a variable a, which is equal to create a matrix. So a matrix is literally, let me get my other dot camera. A matrix can be defined as, you see how this has a corner right here, and this has a corner right here. This is how you define a matrix. You just put a bracket in, and then you can put your number, 1, 2, 3. And that's how you would define a matrix. Matrix A. Alright? Really, really simple. Okay? So we're about to do that right now. So if you type in just that, A is equal to 1, 2, 3, and press enter, and there you go. Now you have a variable. Want to see it? If you go to the workspace and you click here, double click it, and then, aha, you get what you see, which is the whole point of Matrix Laboratory is it's a matrix. It looks like an Excel sheet. So what I'm trying to get to everyone is this is basically a glorified calculator is what they call it, or Excel but with extra steps. Pretty cool. So you can do a lot of things, a lot of signal processing, a lot of data processing if you're ever doing machine learning, if you ever wanted to. So there's that. Now let me define another letter. B is equal to matrix 4, 5, 6. Alright, cool. And there you go. Now we have 2 matrices. Pretty cool, right? So now what I'm going to do is let's call a C, which is equal to A plus B. What's that going to equal? Does anyone want to see our hand calcs? Hint, 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 right there. Okay, I'll point with my finger. Oh, surprise! See, am I not surprising you guys? Is this really simple? You guys getting this? Goodness. I'm just kidding, no, I'm playing. You guys all are gonna learn. But you would be shocked by how many people come back to me saying, it's not adding together. And I'm like, did you check if the matrices agree? Because what happens if I define a matrix? D is equal to 7 and 8. Right? It's a 1 by 2 matrix. If you were to add this to, let's call a vector error, if you want to. So you don't have to call matrices letters. They can be words, phrases. So I'm doing something cool. Error, LOL. Which is going to equal C plus D. So we're adding 2 different size matrices. What's going to happen? Yes, that's our first beep of the day, everyone. So matrix dimensions must agree. And if you want to look at this, you can go to C right here. If you hover over it, you'll see it says 1 by 3. That's a good tip to know, just in case you want to check how big your matrices are. And you see this right here? It's a 1 by 2. So make sure they agree if you're doing any type of elemental addition, subtraction, multiplication. So, but I will show you something pretty cool. So let's do multiplication. So let's first try Matlab's elemental multiplication. So what I'm going to do is the following. So instead of adding this, we're going to multiply this. So if I were to multiply this, 1 times 4, and then 2 times 5, and 3 times 6, what are we going to get? Multiply. We're going to get 4, 10, and 18. Right? How do we do that in MATLAB? I'll show you guys. So if I were to generate a matrix E, you can do that by A times, no, dot times B. So this period right here, this right here is elemental, or it does elemental multiplication. So what it does is, let me point out my camera. It treats this as elements, like you're going to do from here to here, here to here, here to here. You're not treating it as a matrix. I'll show you that later. So if you want to multiply across like this, like this, that's how you would use this elemental multiplication right here. And then what does that generate? Oh, look at that. See, we're getting there. So now everyone's probably asking, well, what's the other multiplication? What happens if I forget that period? Well, error 2, LOL. A times B. So if you remember from matrix multiplication, I'll just pull this out. This camera right here. And let me just get another piece of paper, else someone's going to start barking at me saying, David, your notes are messy. I'm like, I know they are, but try my best. Okay, so if we have a matrix A, which is basically 1, 2, 3, and B, which is 4, 5, 6, right? And if this right here is defined as a 1 times 2 and a 1 times, no, not 1 times 2, 1 times 3, 1 times 3, if you were to do A matrix multiplication with B, they're not compatible. It's not going to work. So I'll show you that. This is going to generate error. Wait. Matrix. Wait. Multiplication. Okay. So let me show you how to generate that error. Here you go. Oh, look at that. And then it tells you to perform element-wise multiplication, use that. And now someone's probably asking me in the chat, hey David, but I want to do matrix multiplication. So let me show you how to do that. There's a special function I want to introduce everyone, which is called this little transformation. It's not like a complex conjugate. It does a transpose of a signal. So the transpose signal or transpose function is basically defined as this. It's a period and this apostrophe. So if I were to do the following, B, if you were to type this into Matlab, what this basically transforms this B is it flips it on its side. It just takes this number and it puts it down like this. 4, 5, 6, and it creates a big column. Pretty cool, right? And then this is defined as a 3 times a 1 matrix. So now if you were to do a cross multiply B period apostrophe, what's your answer going to be for that one? Well, I'll figure this out, but actually, yeah, should we do the math? Yeah, I'm too lazy. But we've already verified our numbers beforehand, but I'm going to tell you it's going to be a 1 times 1 matrix. Pretty good. So let me show you. Oh, there we go. Let's generate F, which is equal to A times B period, and then this little apostrophe right there. So watch the answer. And there you go. The answer is 32. Pretty good, right? How's everyone liking it in the chat? Does B? Yes. Okay, so Abraham asked a good question. So okay, I'll have to explain this right now because in this class, we're going to deal with a lot of complex signals. So e to the j omega, and you know what j omega does? It makes imaginary numbers, which is pretty wild. So what I'm going to try and show you is how to generate an imaginary number. So let's just call a variable. Let's call it M, or capital I, which is equal to 1i. Okay, to define an imaginary number, if you just put in I, or let's see what it does. The function I just creates this imaginary number. But there's another thing you should know. It's 1i also does the same thing too. So you can either do I or 1i, but MATLAB doesn't like I because a lot of CS people use I for I is equal to 1, 2, 5, 4, something like that. Oh yeah, you like that scripting? It's pretty cool, huh? So what I'm going to show you is I is equal to 2 times, I'll naturally try to do this, dot times, just for now, I, but if you want to save room and you know what's going on, creates an imaginary number, right? So, what if I do this? I dot this, right? What's going to happen? It doesn't flip. Oh, because it's not a vector. Sorry. Let me do this. I is equal to, let's create a matrix. I and then 2 dot times I. There we go. Now we have, let me just show you right here. See? Now we have one row with 2 columns. So what we're going to do is we're going to flip this right here. But there's 2 ways of doing it. I'm about to show you what a complex conjugate is. So if you were to do I and just this apostrophe, here's the answer. And look at that. And let me show you the answer right here. See, it flips it. However, it makes a complex conjugate. So be very, very careful with that, unless you know what's going on. And then if you don't believe me, let's do I dot this. And here we go. Now that's our data. It's stored and it's happy as it can be. So as you can see, this I right here, we flipped it, the imaginary numbers. We pulled this right here. And we keep our information. So what I'm going to try and get to everyone is, chat is, thank you. What I want to get to everyone is, when in doubt, use this. Use this to keep info. If you're trying to flip, use this. If you're trying to transpose it, use this function. If you don't use this and you accidentally have an imaginary number, you're probably going to ask like, oh, I have weird numbers and they turned imaginary or complex, and that's not good for when we have complex signals like e to the j omega, and you're like, oh, it's negative now. What the haze? So now let me see. So I think that goes over the, alright, I'm about to get to the meat and cheese of this class, everyone. You guys are all ready? We're about to do your second portion of the quiz. So right now, remember what our answers were? Wait, no, that's the wrong page. Or wait, no, that is the right page. This right here. See that right there? We're about to put this into MATLAB. I want to make sure everyone knows MATLAB is a tool that can help you see and then make pretty graphs. Oh, that's a keyword for the future I'm about to say. Because I'm about to make everyone learn that. So now let's go to our script. So we're about to do some scripting right now. So if you were to turn in an assignment for me, this is usually the format I would like to have, and it's for publishing purposes. So if you do this double % sign, it creates this mega title, like a big title that you see in the front of your page. And actually, let me discuss about that too. If you go to my CMOS EDU page, you go to homework assignments, and you look at the homework guidelines, I prepared a document for everyone's use to look at it. Computer assignments are due at the day and time that has been set by me. Online submissions must be in PDF. Single submissions, physical, easy to scan. And you can read that on your own time, but this is what you would have as a general guideline. How to create a master title, how to create a section title, description, comments, how to create a second title, and then this right here, if you were to put your code in between, whatever you want, will generate a really nice paper. And this is really good just in case you want to show off to your friends and family and be like, hey, look, I can put this on a fridge if I want to. Totally. So, organized computer assignments is a happy grader, so you won't have to go hunting. Let's see, and yeah, you can read all of that. And oh, look at that. That's exactly what your first assignment's going to look like. Pretty long, right? How many pages is that? 29. Who wants to beat that record? Yeah, these are going to be big, long assignments. They're not like long, but they just print. There's a lot of printing. But that's why I prefer doing online submissions, because they're a lot. And then, oh, look at that, it's your answer. Oh, you can just look at it. Oh, look, it's the answer. Whoa, look. Nah, I'm just kidding. I'll show you how to generate those signals. So back to what I'm about to say. This is how you would format your homework. And for clarity and for professionalism, let's start with CLC to clear the command window, clears everything up. And then let's clear vars to do the following. Start off with a clean Matlab. It's nice to have a clean Matlab when you begin. So now the first thing I'm about to do is define a letter n, which is equal to, you can do this, -2 to this colon 2. So this function right here basically creates the following. Note that I put a semicolon in there. I'm about to get to that, really important. So if I were to run this, and oh yeah, I think someone's probably asking how you run this code. Like, how am I doing it without pressing a run button? So there's a hotkey I like using a lot. Let me write that down. To run Matlab. To run Matlab. Section. And that's very important. Section, just a section. Use, let me just remember it. Control, enter. Yes, control, enter. Control plus enter. And that's a really nice hotkey to know. So this runs a section. So back to what I was trying to say. So this little code right here generates a line vector automatically. There's a colon. Use it. It's your best friend. Instead of doing what I'm about to show you, this nasty stuff. 2 minus 1, 0. You see that? It's annoying. Just do this. Oh. 2. And that creates a lot of elements. And then you can make them bigger and have some fun. So now the semicolon. Let's talk about that. So the semicolon is basically, if you put it at the end of your code, it suppresses your code. So it won't spit out whatever it's saying. So this wants to say its name, but if you put this right here, it'll just tell it to, hey, don't say your name, just save yourself. Don't worry, we don't need to know about you. So if you were to control enter, now it doesn't say anything. You have a clear command window. Whatever prints here, by the way, will print on your assignment. So I highly recommend stuff that you don't want to be printed, please suppress it. Because let me show you what happens when someone tries to print this out. If I were to, yeah, look at that big vector. What's this? You want to print this? This right here is probably around 30 pages of wasted paper that's going to get printed out. And if you don't believe me, I'll show you right now. It's 2, 1, 2, okay. Yes, and yeah, it's okay. However, I'm going to try and encourage everyone to, for now, it's shorthand, it's really simple like this. You can just do this. Unless, okay, I'll show you. Okay, I'll show you right now. So suppose you were to do this. Let's do it by twos, right? So see how, okay, look at all this nasty stuff, like 15, 14, 13, right? It's a lot of columns. Now let me run this code. And then look, now it does by twos, 2, 4, 6, 8. And then sometimes if you are really organized at your coding, which I do recommend everyone does, you can call this precision, I think that's how you spell it. I'm an electrical engineer, or actually let's call it prec. 2, and then prec. And there you go, it does the same thing. So oh yeah, that's how you define a variable too. You can define it whatever you want. And then watch this. If I were to do it by 20s, look at that, now it does it by 120, 140, 160. Or very short-handed notes. Very powerful. A lot of tricks you're learning right now. But let me show you what I was trying to do. So if I were to run that, if I were to publish this and submit this to David, let's go edit publishing options. And let's call, oh yeah, you gotta call your code something. Let's call it EE360D lec 1. And let's run that. Oh, where'd it go? Oh, there we go. And then I want to print this using PDF. Okay? And then let's publish. Now you're going to see how ugly this is going to look like. Oh yeah, and it's going to take a while. Oh, what's going on? Come on, Matlab. You're chugging. Yep. Hear that, guys? There you go. Well, okay, it's not that big because I set it to 20, but let me show you. Show you this. 2. Okay, ready? You guys ready? Now, if you already had that set up, you can just press this button to publish or PDF publish. Actually, it's not that bad. It's not that long. 2 pages. But you see this? This is wasted paper. It's not fun. So if you put this there, you're gonna kill trees, and that's not fun. Or actually, you'll just make me have to scroll through it a lot. But yeah, some people do this, and then it gets pretty wild. Alright, so back to what I was trying to do. Let's go to, let's get rid of this. If you want to, you can have that there. Go to 2, and then let's get to the big cheese of this class. Y is equal to minus 2. Actually, let's try this hand. 0, 1, 3, 2. Now you're probably asking, why didn't I put the commas? Well, by nature, you don't have to put the commas. This also creates a matrix. So, but if you want to be organized, you can. So this will also do the same thing. And I'm going to suppress that, and then let's generate that vector. Oh, that's because I'm going to get rid of that. There we go. So now we have our 2 vectors. I'm going to hover over them, and it says 1 by 5, right? And now we're about to do your assignment. So for everyone here, if you were to do my assignment, you're going to type in figure 1, and then we're going to plot your thing. We're using the stem function. We're going to put the x-axis is going to be defined as, see this right here? This pops out. Okay, what you can do with the stem function. The stem function is the most important function of your life for all the DSP engineers, which basically says we're going to use this one right here, where our x-axis is going to be set here, and then our y-axis is going to be set right there. So I'm about to show you that right now. Our x-axis is defined as n, our y-axis is defined as y, and now let's control enter. And look at that. But then you're probably saying, hey David, I can't see that. It kind of looks ugly. Don't worry, we'll make it much more pretty. So, title. Everyone should have a title. Plotting y over n. Okay? And then x label, let's put in n. Y label, which is equal to y. And then for those who are at home, trying to do this at home, that's how you're going to format your thing. And then I'm going to show you a cool trick. So at the same time, I'm trying to show everyone cool Matlab tricks. So one thing I like to do is I like to do this. If I were to draw a line, let me just do a line. Well, not a line, but I'm going to try and do a green one. Actually, yeah, green. This command right here gives me a green signal. Then I'm going to do line of filled, and then let me do line width, and then 3. Okay, see if this works. And then if you were to run this code, oh, look at that. And then wait, let's show you what I'm trying to prove to you, everyone. Okay, there we go. See that right there? And then you see this right there. Oh, come on. See how our hand calculations match our Matlab? You see this 3 right here? It's plotted over there. And here you see how it's middled in the 0? Cool, right? So now I'm about to show everyone another function I have. Let me show you. Let me see if I can pull out an old assignment to help everyone out. Let's pull out this guy, this bad dude. Computer assignment. Oh, you like that? Oh yeah, this is not your guys' assignment. But I'm about to pull out a special function from here. Wait. Nope, that's not it. Come on, where is it? 7, 8. Pull this one out here. Yeah, you can do a lot of stuff on this. Alright, I got a special function for everyone. Oh, and it's almost 6:30. Yep, we're going to do the grid function, but I want to show everyone a cool function you guys can do. So how to create a function? So the way you create a function, and I'm about to just, actually let's just write it down. So if you were to do a function, I'm about to call it pretty graph. Okay, and then let's enter it, n. So now that creates our little pocket function. You can now put whatever you want. This is my favorite function. I've used it for many, many years, and it's always made my graphs look pretty, and they look really nice. So first things first is grid on. So that turns on the grid. You can either do it right here, grid on, and it does this, creates a nice grid. But I don't want to write that all the time. So next thing I'm about to do is AX, which is equal to GCA. And I forget what GCA stands for, but it basically selects the graph, I think. And then, oh yes, it does select the current graph that you're working on. AX, font size, let's make it 12. AX, line width is equal to 1. And then let's set the color of our graph. GCF, the current graph that we're looking at, color. Oof. Now let's call it W. Alright, there you go. So now that's our function. And now instead of doing this crazy code, I'm going to do this. And now, watch this. This function is going to do all this. Actually, I think it's best if actually no, let's just run it. We're running out of time. And then there you go. You have a really nice plot that you can take a snipping tool on, print it out, and have some fun with your Matlab assignments. And, let me just do this. 3. There you go. Pretty thick. I missed it. What does GCA mean? So I think, let me try this. Help. GCA. Let's see if that does anything. Ah, okay. So the next thing I'm about to show everyone, the most important function of today is the help function. If you type in help, never need any help with any function like ylabel or how to use CLC, just type in help and whatever function you want. So it gets the handle to the current axis. So it just basically looks at the current figure that it's on right now. So if our current figure is figure 1, then putting this function right here calls this, but this one's calling figure 1, which means you can edit figure 1. So that's basically what it does. And let me try to rush this right now because I know someone wants to do their assignment over the weekend. Let's look at the assignment very shortly. So look, if you see what I was trying to do, we're basically going over how to do your assignment or read through this. Like if you literally read through this before class, you should be fine. There's some pretty powerful things. You can concatenate some matrices, do this, call something from the matrix. And then, okay, let's just do the first example, first exercise. We're going to go over by at least 15 minutes because that's when the video kind of ended. If anyone has to dip out for a little bit, well, you can be my guest. I'll have this recorded, but I'm going to go over the first example. Let me try this. So generate the following signals for -5 to 5 by typing an explicit list of numbers. So let's see. I think back in the days I made people draw this. Did I draw? Generate the following signals. So back in the days I would make sure everyone would know how to draw this by a piece of paper. So the first thing you guys probably haven't witnessed is a Dirac delta, or a Kronecker delta is what they call it. The Kronecker delta is a discrete pulse. To generate that, let me show you how to do it. So there we go. If anyone wants this additional notes, just teach you guys the 3 most important things: the Dirac, Kronecker delta, the unit step, and the ramp. So the Kronecker delta is basically defined as when is basically this little curvy function. When this is equal to 0, then give me a 1. Else, it's just 0. It's just, or actually, yeah, it's just 1. So in a nutshell, it just looks like this. If I were to draw this again, there we go. Boom, and it just does a 1. And then it's 0 everywhere else. -5 to 5. And remember how we were doing our quiz, right? We were doing our quiz and we were hand drawing it, right? Right? So easy, right? You want to know how many people can't do this? You want to know how many people can't do this? It's just first studying the theory, right? You study the theory in class. You know what it's going to look like on a piece of paper. How can you not plot it on Matlab? So I'm about to show everyone because I know, yep, sadly I need to head to work. Thank you. See, if you have to dip, it's okay, but thank you very much. Make sure to do the warm-up quiz. I want to make sure everyone's aware of that. Let me just write that down. I'm going to probably make an announcement. I want everyone to try to email me. Let me see. Let me just pull this out. This is page 4. And then this is page 5. Page 5. I want everyone to email me their little warm-up quiz just for my grade book to david.santiago@unlv.edu. Subject, let's do EE360D, and then let's just do your last name. And then call it a Q1. There you go. That's what you're going to have on your subject line. So if you want to, you can scan this quiz to me, email this to me so that I can figure out a roll call who is in my class. I don't know who dropped out, or I don't think she said anything about attendance policy thing. Well, the department wants me to do attendance, and I was trying to figure out what's an easy way to give attendance, and I think the best way is, well, the easiest way is just email me this little quiz that we're going to try and do. It's not gonna, I'm not going to try and be like really picky about it. If you're busy, I get it, but the quiz is what's going to give me confidence that, hey, you're at least paying attention, or you know what's going on, you're keeping notes. Where's the practice quiz again? I'm about to mention that right now. That is on this EE360 page that I have, fall 2021, right here. Lecture 1, and I'm about to post a video and the PDF later tonight, and I'll probably put the example right here too, right? But that's what I would want everyone to email me this. Just email me this, scan it, take a picture, or well, at least just let me know that you're alive. That quiz is due on the 6th. Just turn it to me as soon as you can. The sooner the better. If you turn it in tonight, that'd be a pleasure to let me know who's in this class, or whenever you can, but at least before tomorrow, or around tomorrow, today. Just make sure that everyone was at least attending and knows what's going on. So they want me to do this. So yeah, I guess that's how the ECU department works. But let me just do your assignment right now, right? You like that? So this is just for email purposes. I want to know everyone who's in this class and who's attending.
So we just submit a quiz after class every
Yeah.
day?
Yeah, but I'm not going to try and do like weekly quizzes. I'll do them when class is here and try to make sure everyone's actively engaging in this class. I want to make sure everyone. Quiz curved, you're not going to be graded. So they're all self-graded. So that I would have made them graded. However, this is not an in-person class, so this is my bit around through making sure you guys are learning the material. But don't worry, it's all self-graded. So do we do it on a piece of paper or Matlab? No, for this quiz that I have right here,
Yeah, like for number 2.
if you just print this out, plot the function? No, I just say plot it on a piece of paper. Just literally just show me you can do it on a piece of paper. Because this is based on, let me show you. This is based on, wait, not that one. This. So if you can do the quiz, and if you can do this, then you can do this. See how this and this kind of looks like that quiz I was see? If you can do this on a piece of paper, and it's not asking you to draw these signals, it's telling you to generate these signals in Matlab. So if you can do the quiz, then I can trust that you know how to do this. But I'm about to show everyone how to do this. All right? We're going to do the first 3. And is that good for everyone? How's chat doing? Good? All right. So we're going to do the first 3 problems. How do you feel about that now? So do hand calculate, because I don't want anyone saying, we didn't learn that in class. All right. So here's your first hand calculation, the Kronecker Dirac delta. Kronecker, or not the Kronecker Dirac, Kronecker delta. The Dirac delta is the analog version where it's like a spike that goes to infinity with a really tight like area. So the Kronecker delta is this. Now the unit step is basically defined as u of 0, where it's equal to 1, and then anything past n is to infinity, u is always going to be 1. And then else it's u of n is equal to 0. So basically what that looks like is following. If you were to write this at 0, 1, or yeah, let's just do this. So it starts right here. There you go. That's your unit step. Boom, boom. Right? You can draw this by hand, right? -1, -2. All right? So that right there is how you would do it on a piece of paper. Can you do this in Matlab? You already did the quiz. We already went over the example, like the quiz example. If you can do this, you'll be fine. And then a ramp function, which is basically defined as R of n is equal to n, that's pretty much it. So basically, if R of 0 is equal to 0, 1 is equal to 1, 2, 2, dot, 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 you know what I mean, right? It's basically going to look like this. Go 0, 1, 2. If you want, you can go backwards, and that's how you draw it. Everyone getting this? And then make sure you know your axes. Minus 2 to 2, 2, and 2 right there. If you were to do this in Matlab, I'm about to show everyone how to do this right now. Let's do your homework. Exercise 1. And then let's 1A. That's what I'm going to call it. So if I were to clear vars, CLC, n is equal to minus 5 to 5. And we're doing the Dirac delta. So the Dirac delta is going to be, well, okay, let's just do it the shorthand way. I'm going to do 2. I'm going to show you guys this. Minus 2, minus 1, 0, 1, 2. Okay? You know that at n, our Dirac delta has to equal 0. So I'm going to call it delta. That's what I'm going to call it. So if I were to put it in its place, here we want a 0. Here we want a 0. Here we would want a 1. Here we would want a 0. And here we want a 1. So why did I do this format? Because it's easier to see. See, this goes here, this goes here, this goes here, that goes here, right? Right? You see that, right? Right? Figure 2. Stem n delta. And just to save time, because we can't be spending so much time on this. Okay, plotting EX1A, and yeah, let's call it delta of n. Okay, run that. And look at that, and it's not thick. I'll make it thick. Okay, let's copy this. Very nice to have. Okay. And let's color it blue. There we go. You like that? See how our hand calculations are matching Matlab. If you can do this, then you're already on the roll for this class, so you should be fine. Do you guys want me to do the rest of the examples, or do you guys want me to talk more about the assignment? Like, keep going down. Does exercise 1 look simple? Keep going. Okay, we're going to keep going. So, using the signals that you've created in exercise 1, append the signals x and y so that the resulting signal is periodic. Plot your result using the stem function. So let me tell you a hint about this one. So you know how to create this, you know how to create that, right? Here's your answer. Where is it? How to concatenate. Where's that word? I'll just do it right here. I'll show you how to shorthand it. Okay, append the signals. Let me show you how to append stuff. So, it should have been done a long time ago, but appending. Exercise 2A, I think. So if you were to create some vector A, I'm just going to create a vector really, really quick. 1, 2, 1, and is that periodic? No, let's create it periodic. 1, 2, 2. My OCPD is kicking in. B is equal to, let's create this. -1, -2, 1. There we go, like that. So I'm about to do the following. If you were to figure 3, stem, let's just shorthand this. I'm going to try to get everyone out of here. Stem A, title A, and figure 4, stem B, title. Obviously everyone's going to have to make this look prettier than what I'm trying to do. So I just created 2 signals. See how this one's going up like, okay, don't want to get lazy. I want to make sure everyone knows what's going on. Okay, stem, how to do this. Let's color this red. R for red. And let's color this one magenta. M. See that? If you were to put this together, here's a 0 axis, here's a 0 axis. Oh look, I created a periodic signal. See that? Up and down and oh. That should be, let me see, I think I did that one. Oh, -1, there we go. There you go, now it looks more periodic, right? See? Makes sense, right? Going up and down. Now if you want to see that all in one plot, let's create a vector C, which is basically A, B. Right? And now let's get down to business. Figure 5. See how I'm doing a lot of copy pasting? Let's make it black. K. And there you go. Periodic, eh? Pretty cool, huh? You just gotta try and read this assignment, then extract the 3rd sample of this. Let me show you extract something. Let's say we want this from C. This is a 1st point, 2nd point, 3rd point, right? What's this point number? 2, right? So if I were to do C of the 3rd element, I get 2. Cool, huh? So that's how you would do that, so it's pretty simple. Then, using the elementary signals that you created, then generate the following new signals. I guess I'll leave this as an assignment to everyone to have some fun. This right here looks like that elemental multiplication I was talking about. Scalar addition, elemental multiplication. This one's a fun function I put in there just in case. And I think this is a good amount for everyone to start covering. So, is there any questions from the participants or anyone here? Are we good?
So when we submit, we do the publish thing on Matlab?
Matlab? Yes, if you were to, okay, so I'm about to show everyone the coolest thing about Matlab. So if you were to publish this, make sure you go to Edit Publishing Options. Make sure you set it to PDF because PDFs are easier. It's already set right there. But if you already set it up, you can just press this button and then watch this. And it starts printing stuff out, and then look how big the assignments get. Oh, come on. Chug and tug. There you go. See? And now you can look at your assignment. There you go. Pretty nice. Nice, right? And then look, it puts your big title right here too. You can put your name. And I would recommend people, please put your name. By David S. And there you go. Can you show us the pretty function thingy again? Yes. Here you go. But I think I'll upload this. Would be that nice for you guys?
Yep.
I'll upload this code so you guys can play around. And then, well, looks like you guys heard the answer to one of them, the delta, but you just need to know. Actually, okay, if you were to make this look cleaner, from -2 to 2, and since you guys are engineers, I know how you guys can think about that. See, there you go. To make sure you clean up your code. Pretty cool, huh? And then, okay, if you wanted to do 3, right? And 3, make sure you add another 0. 0 and 0. Cool, right? Actually, this looks nasty. Let me show you guys a trick. There's a thing called a zeros function. Zeros, one row of 3 zeros. 1, and then let's do this. Zeros, 1, 3. Pretty cool, huh? And then this does exactly what you want it to do. Watch this. I'm going to show you how to make this more powerful. N1. Yeah, you guys are going to have a lot of good education here. N. So basically what I'm doing here is I'm calling the last point in N and the first point of N. And I'm using this as a number. Watch this. If I were to do 5. Oh, what? What did it bark at? Stem. X must be the same length as Y. Come on. Delta. And, no, absolute. Make sure you put it absolute because it doesn't like a negative. There we go. Look at that. You see that? You can create really powerful code. And watch this. 10. There's your dot. You see that? Now you guys are learning Matlab. Matlab can become a beautiful language if you know how to use it really well. Pretty cool, huh? Alright, so any other questions anyone want me to go over? I'm showing people how to use Matlab's capabilities. You can create really powerful functions, do a lot of things. Oh wait, let me show you guys another trick. Units, step. Let's copy this. You know, if you wanted to generate those zeros, you can also generate ones. Just replace this with 1. And then, if I were to do figure 420. And then, unit step. I'm creating variables, by the way. You can create LOL if you wanted to. Create this one to be yellow. Alright, you guys like the yellow. I don't think so it's going to print. Unit. There you go. Oh wait. But there's your unit step. You see that? Boom! Cool, huh? You guys are getting your money's worth. Any questions? Chat. No chat? What's up? Any questions? Anyone want me to go over more, or are you guys getting your money's worth for now? You guys want to go home?
I got my money's worth.
Alright, so what I want everyone to try to do is try to finish a good amount of the start doing this homework. Don't wait till the last minute. Start going over this. I think everyone here can go over this first page with no problem. Second page, I think everyone should have a fun time knowing what's going on. Just a different range. Should be good. I'm really glad that you guys are having pretty fun. I'm going to help everyone try to get through this class. And everything I've showed everyone right now is just basically some basics, like how to get through this class. You don't have to go buy some crazy resources, but if you want to, be my guest. But with that, I'd like to end the video. Or still recording? Yes. Alright, I'll post this with videos and notes and MATLAB code later tonight. Have a great day, everyone.